Good morning, ladies and gentlemen. We are on day 3 of solving equations with variables on both sides. Today's focus will be infinite solutions. Reminder, tomorrow we will have a quiz and we will wrap our week up with rewriting equations and formulas on Friday. Example, we see 24x plus 36 over 3 is equal to 16x plus 24 over 2. So when we look at our steps, this problem doesn't fit our typical equation. What we want to do in an example like this is go back to what we learned when we looked at cross multiplication. We have two fractions set equal to one another. So you should have reviewed or gone over it previously in math. If I have A over B, then it's equal to C over D. Their cross products are equal. So A, B is equal to B, C. So here, I want to multiply 2 times 24x plus 36 and set it equal to 3 times 16x plus 24. Now, our question or our steps for solving equations fits. It says, can I distribute? Here, I need to distribute on both sides of the equal sign. So my 2 outside is multiplied by everything inside. 24x times 2 becomes 48x. 36 times 2 becomes 72. Again, everything outside gets multiplied times both values inside. Positive 3 times positive 16x becomes positive 48x. 24 times 3 becomes positive 72. So I've been able to distribute. Can I combine like terms? No, I have 48x plus 72. Those are not like terms. Now it says, can I move variables to the left of the equal sign? So the variable terms, or variable term that I have here is 48x. It is positive. To move it to the left, I subtract. Since it's positive, I subtract. Subtraction is the inverse of addition. So minus 48x. Minus 48x. My 48's cancel. I'm left with 72 equals 72. That is correct. 72 is equal to 72. That statement is true. I can't undo addition or subtraction. I can't undo multiplication. I'm simply left with something that looks a bit unfamiliar. No variable, 2 constant terms set equal to one another. Leave a place and I will explain what you are going to put in here in the next example. So, ladies and gentlemen, for example 2. Again, we're back to our steps. First thing is, can I distribute? Yes, I see parentheses. I see a term outside. I want to multiply 2 times everything inside. 2 times x becomes 2x. 2 times 10 becomes a positive 20. Minus 17 equals 5 plus 2x minus 2. Yes, I was able to distribute. Can I combine like terms? So I look to both sides of my equal sign. Here, I have positive 20, negative 17. Here, I have positive 5 and negative 2. Bring down my 2x. Bring down my 2x. 20 minus 17 becomes plus 3. 2x comes down. 5 minus 2 is plus 3. The left and the right are starting to look, again, a bit familiar. What is on the left is equal to what's on the right. I was able to combine like terms. Next it says, can I move my variable to the left? Can I move a variable to the left? Here, I have 2x. 2x can be moved by subtracting 2x from both sides. 2x minus 2x becomes 0. 2x minus 2x becomes 0. 3 is equal to 3. That is a true statement. But again, we're looking for a solution to the equation. I don't have a variable to say x is equal to a value. I'm left with a statement that is true and two terms or two values on both sides of the equal sign. Cannot undo addition or subtraction. I cannot undo multiplication or division. When you get to this step, this is a special type of equation where the solution is infinite solutions. What do you mean by infinite solutions? So in this example, here again, just like previous lessons, the steps that we're following, the process worked out in a manner that I hope is a little bit easier to follow than the steps that I just followed because I'm scribbling on the screen. Either way, we still arrive at 3 is equal to 3. We say that this is an equation with infinite solutions. So since we arrived from this equation to a point where we have 2x plus 3 is equal to 2x plus 3, we have two equations where we've simplified, distributed, and we have terms that we can now substitute. So if I let x equals 4, 2 times 4 becomes 8, where I've substituted the 4 for x. Plus 3 is equal to 4 times 2 is 8 plus 3. 8 plus 3 is 11. 11 equals 11. That is true. Substitute negative 5 for x. Negative 5 times 2 is negative 10. Plus 3 is equal to negative 10 plus 3. Negative 10 plus 3 is negative 7. And negative 7. True. If I let x equal 0 and I substitute 0 in for x, 2 times 0 is 0. So I have 3 is equal to 3. All of these are true statements, and we could substitute any value in for x, and we would arrive at a true statement. So when solving for equations and the variables cancel, if the remaining statement is true, the answer is infinite solutions. When we solve equations and the variables cancel and the remaining statement is true, the answer is infinite solutions. So the three types of equations that we've learned, types of solutions that we've gone over this week. One solution, which is where a variable equals a number. And here are some examples. We looked at no solution. In order to have no solution, our variable cancels out, and the result is a false statement. Example here. If I subtract x from both sides, I'm left with 5 equals 2. But we know that 5 cannot equal 2. In this instance, we would have no solution. And whether it's written as infinite solutions or infinitely many solutions, it is the exact same thing. It is where the variable cancels out and a true statement remains. 6. W plus 6 is equal to W plus 6. At the step where I move a variable to the left and were to subtract W from both sides, we will be left with 6 is equal to 6, which is an indication that we have infinite solutions or infinitely many solutions. For today, do not forget to complete your Get Started. Homework 1.3C will be due tomorrow, and we will resume tutoring next week on Tuesday from 2:30 to 3:30.